looks at the recording, but it's posted within a day or two of when the class takes place. Very important if you missed a class that you can make it up. So we're recording this now, and we're looking at this first equation. Both of these are what we call quadratic equations because they have x squareds in them. And we're going to be using the form of completing the square. Even when I look at the answers, I know that it wouldn't be able to be broken up into two parentheses because there's no way I would get square roots in my answer that way. So I really don't have a choice but doing this new method called completing the square. And what we do is we take the first two terms, the terms that are with x, and we put them in order if they're not in order. In other words, the x squared term has to be first, the x second. And on the other side, we put the 5. Now, it happened to have been set up like that. If it's not, we have to set it up. It's the only one of the methods that are used to solve quadratic equations where you only have the x's on one side and the number on the other side. And what we're going to do is we're going to add something over here, a number over here, that will make this x squared plus 8x a perfect square. And it's going to be, we can even figure out what it's going to be, what's going to be in the parentheses. There's going to be an x. This sign is plus, so there's going to be a plus. And the number that's going to go here is half of this number. It's divide the number in front of the x by 2, you get 4. So this will give you x plus 4 squared, but that'll only work if we have a third number over here that is a perfect, that makes this into a perfect square. And it's easy to figure out the number. You take this number, that's half of this x, you take it and you multiply by itself. 4 times 4 gives you 16. In other words, x squared plus 8x plus 16 is x plus 4 squared. We explained why that was the other day. We saw that's the pattern. The first number, when you have a binomial square, the first number is the first term squared. The last number is the last term squared. And the middle number is just these two multiplied together, multiplied by 2. Now, we added 16 over here, which means we have to add 16 on the other side. That's the most important thing to remember. Whatever, when you have an equation, whatever you're doing to one side of the equation, you're doing the exact same thing to the other. So it turns out that this x plus 4 squared is 5 plus 16, which is 21. And now we're going to use our square root method. We'll take the square root of both sides. So this side will just be the x plus 4. And on the other side, the side that doesn't have this square on it is going to be plus or minus the square root of 21. And then what you're going to do is you're going to get the x alone. You're going to bring this 4 to the other side. So you're going to subtract 4 from both sides. And if you recall, I said the number that you bring over, always put in front. That'll be the format you will see. It's not wrong to put it as a negative 4, but you'll never see it in that form. So this will give us negative 4 plus or minus the square root of 21, which is indeed choice A. And look at how similar the answers are. You really have to be careful when you're doing this watch your signs and be careful. Okay, so I think most people got that one right. Let's look at the next example. This is also a quadratic equation, and again, I can see right away you can't factor it because there are no numbers that multiply to 29 that when you add them will give you 4. It just doesn't work. So what we're going to have to do is bring the 29 to the other side So we can use this completing the square method. Mind you, this completing the square method could work even if it's factorable, but usually the factorable method is the easier way to go. But if you don't like factoring, you could always do this method. So what you'll have is x squared minus 4x, and we're leaving a blank equaling negative 29. Okay, and again, like we did before, we're going to want to figure out add something to the x squared minus 4, complete the square, that will make this x squared minus 4, we need a trinomial, make it a perfect square trinomial, a binomial squared. So we know the first thing is going to be x, and the second number is going to be half of the negative 4, which is negative 2. So in my parentheses is going to be the x minus 2. And what I have to add over here to make this a perfect square is this negative 2 times negative 2, which is plus 4. So again, in completing the square, there are two things you do. To find the number, you divide the number in front of the x by 2. Negative 4 divided by 2 is negative 2. You take that number and multiply by itself. You square it. Negative 2 times negative 2 is 4. And that tells you what to add to both sides. And I only added it to the left side. I have to add it to the right side as well. So that I end up with negative 29 plus 4, which is negative 25. And again, I use my square root method. I do x minus 2 over here, and we take the square root of this, so that takes care of the square. And on the other side, I'm doing plus or minus the square root of negative 25. Don't forget, this is a negative, and that means it's the square root of 25 times the square root of negative 1, which is 5i. Don't forget, when there's a negative inside a square root, that's going to give you an I. So this will give us x minus 2 equaling plus or minus 5i. And like I did before, I'm going to bring the 2 to the other side, so that I'm going over here because I'm sort of running out of space. X equals 2 plus or minus 5i, which actually is short choice D. And unless there are any other questions about this, I'm going to show you an additional method that can be used to solve quadratic equations. And this method is so important. It's based on a formula, and you're going to have to know that formula by heart. And you're going to have to know how to use the formula. But once you know that, you can use it on any quadratic equation. No restrictions. It doesn't have to start with just a plain x squared. It could have a number in front of the x squared. It doesn't need to have a number in front of the x that's even. It could be any number. And it could be factorable or not factorable. It's a method that's useful and needed to be used in any time you're dealing with quadratic equations. Okay, so let me show you that method. And then we'll talk about doing some problems and practicing with it. Okay, so let's say I gave you an equation that looks like this. the one that will give us a good. Okay, suppose I gave you this equation. 2x plus 3 equals negative 2x squared. Okay, we want to solve this quadratic equation. I know that it's a quadratic equation because it has an x squared in it. Anytime you don't, if this would have been just a plain x, then we would have had a linear equation. We solved those. This is the quadratic equation. And in order to do that, we want to put it in what we call the standard format, where we're going to have the x squared term first, the x term second, and the number third equaling 0. So the first thing I'm going to do is I'm going to add 2x squared to both sides. And that's going to equal 0. Now notice I put it, when I added the 2x squared, I put it at the front because I want it in the standard format, what we call descending order. Now there are 3 important numbers here that we're going to see. And in every quadratic equation, there are these 3 important numbers. One number we're going to call the A, one number we're going to call the B, and one number we're going to call the C. The A is the number in front of the x squared, which in this case is 2. If there is no number in front of the x squared, then it's understood that it's the number 1. The B is the number that's in front of the x. Whenever you're doing this, always include its sign. So if this would have been a negative 2x, my B would have been negative 2. But in this case, my B is 2. Also, if there's no B, let's say the equation was 2x squared plus 3 and there was no x term, the B would be 0. And the C is what we call the constant, the number that stands alone, which in this case is 3. So that's the first thing you have to do when you're going to be using the formula. You have to find out what the A, the B, and the C is. Somebody has their mic open. It's a little bit annoying. Now, so the first thing you're going to have to figure out is what is the A, what is the B, and what is the C. And the reason for that is because those are the numbers you're going to be fitting into this formula. Here's what the formula looks like. It's called the quadratic formula. And it's x equals negative b plus or minus the square root of b squared minus 4ac divided the whole thing, the whole expression divided by 2a. Now it's a complicated looking formula. You have to memorize it. You have to get familiar with it. You have to know it by heart. How do we use this formula? Notice I said x equal because this is going to give us the answers to the x. I'm going to take the numbers that I have over here and I'm going to replace them. So the first number is going to be negative. Now I'm going to put a parentheses where each letter should be. And in the parentheses, I'm going to fill in the numbers. So this is going to be -2. Plus or minus, this is where I have to really be careful, especially with the signs. The next thing is b squared. Again, in place of that b, I'm putting a 2. -4, now one number is going to be an a and one number is going to be a c. Now the a happens to be 2 and the c happens to be 3. And the whole thing is over 2 times a, which is 2 times 2. So step number, and I always do this. I write down what my a, what my b, and what my c is, being very careful with the signs. And then I write down my formula, and the next thing I write down is the numbers replacing the letters. Now what we have to do is simplify. And most of this stuff we know how to do. So this is -2. Don't need that parentheses. Big thing is the number inside the radical. So 2 squared is 4. And -4 2 times 3 is 4 times 2 is 8. And 8 times 2 is 24. So it's 4 minus 24. Which is -20. Be careful with those signs. So this is going to be plus or minus the square root of -20. And this is all over 4. Now, truthfully, we've solved the equation. But you know that this is not the way the answer is going to be written in the multiple choice. So what we have to now do is simplify. And the first simplification that we want to look at is the radical. We have the square root of -20. Do we remember how to simplify that? And the answer is, remember, we break it up into 2 numbers, well, actually 3. One of the numbers is going to be a -1. And the 20 I can break up into 4 and 5, where the square root of -1 is going to be I, and the square root of 4 is going to be 2. So this will come out to be 2i. Remember, I told you I always like to put the I in front of the radical, square root of 5. So here we are. Replacing the square root of -20. So it's -2 plus or minus 2i radical 5 over 4. Now I want to erase this because I just need the space. So everybody remember how we did that. Notice how everything in this course, one thing builds on the next. Well, now we're going back to something that we learned with dealing with fractions. We can separate this. This is a binomial over a polynomial, but over a monomial. It's one number in the denominator, 2 numbers, 2 terms in the numerator. Remember, we said one of the things we could do when we're dividing is put each one separately over the denominator. So the next thing I do, especially when I see it, because I want to get my answer in what we call a plus bi form. I didn't know ahead of time that this was going to give me i's, but if I'm doing it, I want to get it in a plus bi form. Well, the first term is -2 over 4. Well, that can be reduced to -1/2. And the next thing, we have plus or minus. The 2 and the 4 can be canceled out. This will give me a 2 on the bottom. And what I'll be left with is I radical 5 over 2. And it doesn't look so nice or pretty, but this is the answer to our quadratic equation. If you noticed, it was not factorable. And not only that, it wasn't even a good setup for the completing the square method because there was a number in front of the x squared. But we were able to solve it, and any quadratic equation can be solved this way using the quadratic formula. Okay, I'm going to do another one with you. First of all, let me write the formula over here on the board so we have it. I'm going to leave it here. X equals negative b plus or minus square root of b squared minus 4ac over 2a. So important that if you're snoozing in class and I wake you up and I say, hey, what's the quadratic formula? You should be able to rattle it off. So is there any question of what we did here? So I want to go back to one of the questions we did before. As a matter of fact, I'll go back to both of them. Let's do the two questions that we just did using the completing the square method. Let's do those with the quadratic formula method. I'm going to show you that it doesn't matter which method you use because you will get the exact same answer. The big thing is to be careful about simplifying. Example. Should have them written down. Okay. Here was the first example I had given you. It was x squared plus 8x equals 5. That was and I had told you to solve it by completing the square. We're now going to use this new method to solve it. Now, I'm going to work this one completely out, then I'm going to give you the next one to try on your own. So I know when I'm using the quadratic formula, I have to get it equal to 0 in standard form, x squared x number. So the first thing I'm going to do is bring the 5 to the other side. So that'll give me x squared plus 8x minus 5 equaling 0. And the next thing I'm going to do is I'm going to write what the A, what the B, and what the C is. I like to write it down. I don't like to just, because if I'm not careful, I might get something wrong. Well, the A in this case, well, there's no number in front of the x squared, so the A is 1. Remember, the A, B, and C are just plain numbers. They have no x's in them. The B is the number that's in front of the x term, which is 8. And the C is the number that doesn't have any x connected to it at all, which in this case is -5. Don't forget to include the negative. Okay, once we have our A, B, and C, we can replace the numbers by the letters in the formula by the numbers. So here's our replacement. Remember, I'm going to put a parentheses where every letter is, and then fill in the parentheses. So the first parentheses is negative B, so it's going to be -8, plus or minus. The next thing is B squared. Notice the number goes inside the parentheses, so it's 8 squared, minus 4, parentheses for A, that's 1, and parentheses for C, which is -5. Be careful with those signs. And this is all over the whole thing, not just the square root part, but the whole thing is over 2. Here's my parentheses for A, which is just 1. Okay, and now we're up to simplifying. Again, negative in a 8 is just -8. Then it's plus or minus. Here's where we really have to be careful. 8 squared is 64. And -4 times 1 times -5 is plus 20. And 64 plus 20 is 84. And on the bottom, it's 2 times 1, just 2. Now, the big thing is this 84. After we've done that, sometimes this is an easy number, but the square root of 84, we want to be able to simplify it. And I do that by breaking up 84 into 2 numbers. So if I divide 84 by 2, I'm getting 2 times 42, which is no good because neither 2 nor 42 is a perfect square. Let's try it dividing by 3. 84 divided by 3. Notice I'm using my calculator because these are not such easy numbers. Is 28. 3 times 28. Well, neither 3 nor 28 is a perfect square. And the next thing I do is 84 divided by 4. And that's 21. 4 times 21. Well, that's good because 4 is a perfect square. So I can write the square root of 84 as the square root of 4 times the square root of 21, which then becomes 2 square root of 21. So this then simplifies to -8 plus or minus 2 times the square root of 21 over 2. And we could do what we did before by separating them, because it's a binomial divided by a monomial. In other words, this is -8 over 2 plus or minus 2 times square root of 21 over 2. And the -8 divided by 2 is -4. And here the 2's just cancel out, and you're left with the square root of 21, which is exactly the answer we had gotten before. Now, if you ask me, in this case, it was obvious that we could use this completing the square method because this was just a plain x squared, and this was a number in front of the x was even, so it was a setup that was good for completing the square. I think the completing the square method is a little bit easier, but again, if you only want to learn one method, then you have to learn the quadratic formula method, because there are cases where the completing the square method doesn't work, and we have to use completing there are methods where the completing the square method doesn't work, and we have to use the quadratic formula. Are you ready to try the next one using the quadratic formula? Okay, let's do one more, and while you're doing this, I am going to be taking attendance. Okay, again, it's going to be the one that we did before. That we did where we had x squared minus 4x plus 29 equals 0. We did this with the completing the square method because it was a good setup. The number in front of the x squared was just 1, and the number in front of the x was even. That's a very good setup for completing the square. But let's now do it with the quadratic formula and see that you're going to get the exact same answer, as long as you're careful when you simplify. Okay, while you're doing that, I'm taking attendance. Olivia, Isis, good morning. Elvira. Lewis Hart. Emma.
I'm here. Good morning.
Good morning. Demetrius.
Good morning.
Good morning. Desmond. Shania. Shania. Caden. Kayla. Kayla. Hi, good morning.
Good morning.
Sanjita. Oriana. Oriana, I know you're here.
Yes, I'm here.
Okay. Tahira, I know you're here also. Michaela. Tiana. Tiana here. Carleaf. Jenna. No, hi, Carleaf. Yeah. Jenna, you here? Tatiana. Hi, good morning. Naya, I know you're here. Kazanda. Trina. Trina Small. Jean. Jean? Good morning. Okay, got everybody now. I check afterwards on the participants to see if I missed anybody. So I see I got everybody. Okay. Okay, so let's go ahead and do this example using the formula. Does anybody want more time? Okay. And again, we're going to check that we get the same answer. Okay, first step. What is the A? What is the B? And what is the C? So the A is 1 because it starts with a plane x squared. The B is -4. Be careful, there's a negative in front of that. And the C is 29. Okay, so now I'm going to substitute these numbers into the formula. So remember, I put a parentheses wherever that a letter is there, and I fill in the parentheses with the proper number. So it's negative, in the parentheses is going to be a -4. Plus or minus, parentheses b squared. Well, the b is again -4, so it's parentheses -4. Don't do this on your calculator and just put in -4 squared, because you're going to get, it's going to think that you just want to square the 4. You have to put in the parentheses. And this is -4. Your A is 1, and your C is 29. And this is all over 2 times 1. Okay, so now we're up to the simplifying. Again, I suggest you have a calculator handy if you want to do this. Okay, be careful here. This is a negative, 2 negatives. A negative and a negative becomes positive. So this becomes 4 plus or minus. Okay, so now I have to do the square root. The -4 squared is positive 60 minus, okay, so we have, I'm doing this on my calculator, 4 times 1 times 29, which is 116. And 60 minus 116 is -100. So this is plus or minus the square root of -100 all over 2. And now we're at our simplifying stage. We have to look at the square root of the -100. This is where negative 100, I'm sorry. This is where we're always going to be careful, which means it's the square root of 100 times the square root of -1. So that's 10i, because 100 is a perfect square. But don't forget that negative means it's I. So we have 4 plus or minus 10i, all divided by 2. Don't forget dividing by the bottom. And again, we separate it. And we do 4 over 2 plus or minus 10i over 2, which simplifies to 2 plus or minus 5i, which is exactly the answer we had gotten before. Again, be very careful with the numbers and their signs so that when you simplify, you're getting the right answer. Any question? Anybody have any questions? Okay. Let's do one more like this. I'm going to give you again, I think it's one from a final exam. See if I can find one. Okay. Here's the question. And since it's a final exam question, we can do it as a multiple choice. The question is 5t squared minus 7t equals 1. And that doesn't matter that they're using a variable t instead of an x. You're just going to think of it as an x. And here are the answers they're giving you as the possible answers. 7 plus or minus the square root of 69 over 10. Answer number 1. B. 7 over 10 plus or minus the square root of 69 over 10i. Negative 7 plus or minus the square root of 69 over 10. And choice D is negative 7 over 10 plus or minus square root of 69 over 10i. Okay. And if you notice, the answers all look really similar. So you really have to be careful on this. Okay, I'm giving you a few minutes to try it. Okay. See, I see somebody has answered. Ariana gave me an answer. And Kayla, let me give you extra credit for that, and we will see if you got the right answers, but let me put on the rest. I think it's time to try it out. And it's obviously a quadratic equation because it has the square, the variable squared. And it's certainly not one that I would want to use the completing the square method with, because the number in front of the square term happens to be 5. It's not 1. But in order to do that, the first thing we have to do is bring the 1 to the other side. So that we are going to have 5t squared minus 7t minus 1 equaling 0. And now I can write down what my a, my b, and my c are. My a is a number in front of the square term, that's 5. The b is a number in front of the t, which is the plain number without a square, which is -7. And the c is the standalone number, which is -1. Okay, so these numbers I have to stick into that formula. So here we go, negative parentheses -7 plus or minus the square root. Here we're going to have to be really careful. Parentheses -7 squared, there's my b squared, minus 4 parentheses a, which is 5, times parentheses c, which is -1. And that's all over 2 times 5. Okay. All right, negative and a negative become a positive. So that's +7 plus or minus. Now here's where we're going to be careful. -7 squared is 49. And -4 times 5 times -1 is +20. Because there's a negative times a negative, that's making it a positive. So 49 and 20 is 69. And that's all over 10. And that's exactly choice A. Notice it's not choice B because there's no negative inside the square root. So there's no I. Right away, when I saw that this was going to be a positive number, be very careful with those signs. -7 times -7 is +49. And -4 times 5 times -1 is +20. So we got +69. No I's in it. So I could right away, let's count choices B and D. And if I look at A and C, I have to just be careful. There was a negative and a negative that made it positive. The whole thing here was being careful with the signs. Okay. That being the case, I want to go on, still have some time. The next topics we're going to be doing, it happens to be, we're going on to chapter 9. We're going to get back to chapter 8, but right now we're going on to chapter 9. And the reason is because chapter 9 is really, in many ways, a continuation of what we've been doing. We've been talking about quadratic equations. We've been talking about how to solve a quadratic equation. And at this point, we know exactly how to solve a quadratic equation. We have 3 methods. One is the factoring method, which obviously doesn't always work because you can't always factor. And sometimes you can factor, but it's very hard factoring. The second method is the completing the square, which we said we only want to use if we start with an x squared, no number in front of it. The a, in other words, has to be 1. And the b, the number in front of the x, has to be even. That's a good setup for completing the square. And if I see that, I use it. But if I have any other situation that I don't want to factor, and I don't have a good setup for the completing the square, that's where the quadratic formula comes in. We use the quadratic formula. We're going to be doing this, practicing this quite a bit, because probably of everything that you learn in this course, this is one of the most important things you learn, how to solve a quadratic equation. Okay. Well, if you think back to how we started this course, the first thing we talked about was solving what we call linear equations, equations that didn't have any squares in them. The highest power was 1. And after we talked about solving linear equations, we talked about graphing linear equations. And we said one of the reasons that what we call first degree equations that don't have any exponents in them, linear equations, is because when we go to graph them, we get a straight line. And we usually, what we did, we put it in the y equals mx plus b form. And then we saw the slope and the y-intercept, and we were able to graph it. And after we graphed it, we also learned how to write in a linear equation. So that's one of the things we did at the beginning of the term. We're going back to graphing now, but now we're going to be graphing quadratic equations. And we're going to see there isn't just one type of picture you can get when you're graphing a quadratic equation. There are basically 4 types of figures. The first one we're going to be talking about is something called a parabola. It turns out that a parabola has the form y equals ax squared plus bx plus c. In other words, it looks like a regular quadratic equation, except instead of a 0, it has a y. Well, we know when we're graphing that we have the same thing with regular equations. We first solved regular equations, then we did equations that had x's and y's. In a quadratic equation that's going to give us a parabola, it's going to be y equals x squared, an x, and a c. In other words, there's just going to be plain y. There's not going to be a y squared. We'll talk about what happens if there's a y squared but no x squared. In other words, there's a degree 2 on the x. There's a exponent of 2 on the x, but the y has no exponent. And we set it up y. Sometimes it's also, we remember we use that functional notation, where instead of y we called it f of x, we could call this f of x equals ax squared plus bx plus c. That is the setup. And again, the y and the f of x are equal. You can call it y, you could call it f of x. They mean the same thing. F of x is just another name for y. And when you have something that looks like this, the shape you're going to get on the graph is going to be a parabola. Now, you might have heard of parabolic shapes, so you might know what it looks like, but I'm going to tell you. Basically, what you're going to get is what we call a U shape. That's how the parabola, if you plotted a lot of points, if you put in different values for X and you found your values for Y, you get this shape. Sometimes a U upwards, and sometimes the U is downward. Not both, it's one or the other. But if you notice, what you have in a U shape, it's not exactly U shape because the sides keep going out further. They don't go straight up, they keep going up. But for our purposes, it's easy to call it a U shape. Or a hill, this is a valley, this is a hill, you could look at it that way. What you might notice as the most important thing that you might want to notice is this one point here or here. Over here, this is what we call a minimum point. And over here, of course, this is not a minimum point, this is a maximum point. This is the lowest point because it's opening up. This is the maximum point because it's opening down. This has a highest point, this has the lowest point. How are you going to know ahead of time whether your parabola has a minimum point or a maximum point? Well, that's going to be very easy. You're going to look at the A. If the A is positive, your parabola is going to be opening up. It's going to be an upward shaped U, and it's going to have a minimum point. If your A is negative, you're going to have a downward facing parabola, a downward facing U, and of course then it'll have a maximum point. Now, how are you going to remember that? If you look at this, this looks like a smile, and this looks like a frown. Well, when you're positive, you have a positive attitude, you're smiling. But when you have a negative attitude, you're frowning. So that's a good way to remember whether it's which way your parabola is going to go. If we wanted a generic name, and not for what this maximum minimum point is, we sometimes call it the vertex. And again, the vertex can either be a minimum point or a maximum point. It can also be called the turning point. So there are a number of different names that this could be called. And one of the things that's going to be very important for us to find out is, where is this vertex? Where is this minimum or maximum point going to be? Notice, if I know that, if I know where the minimum point is, and I know it's a minimum point because the A is positive, I could probably do a pretty good sketch of what this parabola is going to look like. So what I want to do is I want to give you an example and show you how it works. So suppose I gave you this equation. Y equals x squared plus 2x minus 3. This is an equation of a parabola because it has a y, but no y squared, and it has an x squared. It is going to be a parabola. And in this case, let's write down what the A, the B, and the C are. The A in this case is obviously 1 because there's no number in front of the x squared. The B is 2, and the C is -3, which tells me that I am going to have a parabola that opens up. It's going to look like a smile. Now, the first thing I want to do when I'm looking for to graph a parabola is I want to find its vertex. In this case, I know my vertex is going to be a minimum point because we're going to have an opening up parabola. And there's a formula for figuring out the vertex that you must know by heart. It goes like this: x equals negative b over 2a. Now we just wrote down what the a, the b, and the c are, so we can substitute these numbers. It's going to be negative 2 over 2 times 1, which will give me negative 2 over 2, which is negative 1. Now this is not really the vertex, because a vertex is a point, and a point needs not just an x value, it needs a y value as well. So this formula only gives you the x value of the vertex. To find the y value, you have to go back to the original equation and replace the x by negative 1. So this is going to give me negative 1 squared plus 2 times negative 1 minus 3. And if we simplify that, negative 1 squared, be very careful here, is positive 1. 2 times negative 1 is negative 2 minus 3. And 2 minus 1 is negative 1. Negative 3 is negative 4. So the vertex is the point negative 1, negative 4. Okay. So finding the vertex is not very difficult as long as you remember the formula. Here's the point, negative 1, negative 4. So the vertex is right here, and I know it's opening up. Now, I don't know how wide to open it or how narrow. So aside from finding the vertex, there are two other things we can find. That is the intercepts. It would be nice to know where this parabola is crossing the axes. We can find the y-intercepts and the x-intercepts. And the method that we're going to use is I think we mentioned it when we did lines, but this works for any kind of graphing. Let's first find the y-intercept. To find the y-intercept, in your original equation, replace the x with 0. Why do we do that? Because the y-intercept, the y-axis, is where it's crossing the y-axis, and at that point, the x value is 0. So if we go to our original equation and we do y equals 0 squared, we want the y-intercept, so we're replacing the x with 0, plus 2 times 0 minus 3. Well, 0 squared is 0. 2 times 0 is 0, so this is 0 minus 3, which is just negative 3. It actually always comes out to be the c value. In this case, the y-intercept is the point 0, negative 3. So here we go. I'm putting that in. Here's 0, negative 3, it's right here. Okay, so we already have 2 points. Going to, I guess I'm going to go over here. I also wanted to find the x-intercepts. And we do the x-intercepts in a similar manner that we did the y-intercept. In the y-intercept, we replace the x with 0. If we want the x-intercept, we replace y with 0. So anytime we're doing a graphing, and this is not just parabolas or lines, any kind of graphing, if we want to find where the graph crosses the y-axis, just replace x with 0 in your equation. If you want to find where the graph crosses the x-intercept, replace the y in the equation with 0. Well, if we do that, we get 0 equals x squared plus 2x minus 3, which means that what we have here is a quadratic equation that we have to solve. Now, it happens to be, you could solve this with a formula, you could solve it actually with completing a square, but it actually is factorable. This is not hard to factor. The x squared is x and x. Remember, when your last term is negative, one is going to be plus and one is going to be minus. And we need two numbers that multiply to 3 and subtract to 2, which obviously is 3 and 1. And since the middle term is positive, that means the larger number, the 3 is going to be positive, and the 1 is going to be the negative. And we set each of these equal to 0. So when we get x plus 3 equal to 0, we get x equals negative 3. And x minus 1 equal to 0 gives us x equal to 1. We get, there will always only be one y-intercept, but very often there are two x-intercepts. Okay, let's plot these 2 points. So one is at negative 3, negative 1, negative 2, negative 3. In other words, this is the point negative 3, 0, if you want to write what it actually is. And the other point is 1, which really means it's 1, 0. And here we are. And notice I can now easily draw my parabola by connecting the points. So drawing a parabola, first of all, knowing that it's going to be a U-shaped, it probably should be a little bit, mine maybe is a little bit too pointy at the bottom, maybe it should be a little bit rounded. But basically, this is what your parabola is going to look like. And you get it by finding, as I said, really one major important point, the vertex, and then the x and y intercepts. Let's see if we can do another example. Okay. Here's an example. I'm writing another one on the board. Suppose I gave you that f of x is equal to negative x squared plus 2x minus 5. Okay. I want you to, here's what I'd like you to do. I want you to write out what the A, the B, and the C is. And tell me if it opens up, if it's upward or downward. And also see if you could figure out what is the vertex. And I'm going to give you a few minutes to try that. Okay, let's see what we can do with this. Number one, let's write out what the A, the B, and the C is. Remember, this could have also be written as Y equals. So it doesn't matter if they call it f of x or if they call it y, it means the same thing. So the A is the number that's in front of the x squared, which in this case is -1. Don't forget it's a negative, which right away is telling me, since the A is negative, that it's going to be facing downward. It's being upside down, it's going to be a frown, which means that what we're going to have is actually our vertex is going to be a maximum. The B is 2, and the C is -5. Okay, so we figured out that we have a downward facing a parabola, and the vertex we're going to try and find by doing x equals -b over 2a to get the x value. and put that into the equation to get the y value. So this is going to be -2 over 2 times -1, which is going to be -2 over -2, which is just 1. Negative b over 2 times a. Now that's the x value. To find the y value, we're sticking it into the equation. So it's going to be -1 squared. Remember, I'm putting, in place of the letter, I'm putting a parentheses, plus 2 times 1 minus 5. Just have to be careful with your numbers. So be careful here when it says -1 squared. It means to square the 1. 1 times 1 is 1, and then multiply it by the negative. So that's -1. It's not the -1 that's being squared. It's just the one that's being squared, and there's a negative in front of it. The next is 2 times 1, so that's 2. And then there's minus 5. So -1 plus 2 is -1, is positive 1. And 1 plus -5 is -4. So now I know what my vertex is. My vertex is the point x is 1, y is -4. Just going to sketch this. Just putting in the information that I have now. 1, 1, 2, 3, 4. Here's my vertex. Now, the other two things that we did was find the x and the y intercept. So to find the y-intercept, we replace the x with 0. And if I replace the x with 0, I get y equals -5. We're not surprised. That's what the c is. Right here. What about x-intercepts? Well, guess what? I just told you this is a downward facing parabola. That means it's going to go like this. Not very good. Which means it's never going to get high enough to cross the x-axis. So there's going to be no x-intercepts. And let me tell you what would happen. If you try to solve that equation, you get answers with I in them. And I can't be graphed because there are no x-intercepts. So this is, if you were doing a sketch, all you'd find is the y-intercept and the vertex, and you'd be able to do a sketch because you'd know it was facing down. Okay. All right, this is where we're going to continue with next time. Make sure to look out for Delta Math homework, and there's shortly going to be a quiz on Delta Math, but there's new homework that has been posted. And just to keep in track, we have class on Friday, and we have class next Monday and Wednesday, but the following Friday, which I think is the 25th of November, that's Thanksgiving weekend, and we do not have class then. So just keep track of where you're at. Anybody have any questions? Okay, then I'm going to end class right now. Have a good day.